Hello everyone, welcome back to my YouTube channel. In this video, I'm going to discuss on vector database, Hugging Face, and Facebook AI similarity search. Let's first start with basics. What is vector database? Imagine you have text, image, or video, and you have converted them into numbers. These numbers are called embeddings, and these embeddings are stored inside a vector database. Each embedding can have multiple numbers, and these numbers are called dimensions. Each embedding can have a dimensions like 364, 512, 768, and even more. Now, the question that comes into our mind is how can we calculate these embeddings? For this, we require Hugging Face models. Now, the question that comes into our mind is what is Hugging Face? Hugging Face is a platform that contains AI models. These models can convert sentences into embeddings. Suppose we are having a sentence like I love cats and we have passed it to a Hugging Face model. Now it will convert into numbers and these numbers are called embeddings. All Mini LM-L6V2 is the model that we will be using today in our implementation. It is fast, it is small, and it is very good. Now we have got the embeddings, and the question that comes into our mind is if we are having a huge number of records, how can we find similar vectors? So here Facebook AI similarity search comes into the picture where we can find similar kind of vectors in an easy way. It is an AI tool developed by Facebook to find similar vectors. But how does FAISS knows which vector is closest? For this, it uses cosine similarity. Cosine similarity is angle between two vectors. Where angle is more, there is less similarity. Where angle is less, there is more similarity. It is calculated as dot product of two vectors divided by multiplication of their magnitude. Suppose we are having two vectors A as 101 and B as 0.8, 0.9. We have calculated their dot product and we have divided them by their magnitude multiplication. Now the answer that we got is 0.998. It tells that both the vectors are aligning in the same direction and they are very close. Now let's start implementation of this with Python. Suppose we are having millions of vectors and we need to find which are closest. How can we do that? Let's write the solution in simple steps. Firstly, we require to load the model. Then we require to create the embeddings of our sentence. Then we need to create the FAISS index of our embeddings. Then we need to search using the query. So these are the simple steps in English. Now let's implement this with Python. First of all, we will create Python file. Once the file is created, we will start importing the libraries, sentence transformers for Hugging Face models, then FAISS for vector database, and then NumPy for simple mathematical operations. Once importing is done, we will move to loading the model. So we will be using the sentence transformer to load all mini LM V6 L2 model. All mini LM L6 V2. Once the loading is done, we will pass the sentences that we want to load in our vector database. We can pass in it in the form of list only. So we can give 2, 3, 4 and number of sentences. Here we are giving only 3 sentences. Once we are done with creating the list, we can encode them into embedding. Yeah, model.encode, and we can pass the sentences. Once we are done, then we can move to FAISS steps, where we can first of all know the vector size and storing them into the dimension. And then we can go for FAISS index. Here we will be using the Euclidean distance L2. It calculates the distance and it stores the value. Now once it's done, we can store this index. We can store this embeddings into our index. Now we can search what we have created in the form of query. We can firstly encode that what we want to search. And then we can do the index search. Here d is the distance and I is the indices. K is equal to 2 means we want two closest vectors. Now we can print the closest sentences. Now for idx and I0 means I0 means here that it's a 2D array and we are converting it into into 1D. We are passing a list only. So now we can execute this code. Yeah, it got failed. It should come L2 dimension. We need to update this in our code and we can re-execute. Yeah, it's L2 dimension. Now we can execute this and we can get the two closest sentences. Yeah, it has given the two closest sentences. So this was all. Thanks for watching my video. In the next video, I will be coming with the new generative AI series video. Thank you.